Today we're at the 17 Mile House in Pebble Beach, and we're talking ventilation and heating and cooling system. Today we're at 17 Mile House, and we're with Bronwyn Berry, the architect, and Rob Nicely, the builder of this project. And Rob, this house is a passive house. So we all know about passive house, and they're really about reducing the amount of energy that we use, and it really has to start with the design. But we got a heating and cooling system here, which honestly looks really tiny. Tell me a little bit about what you've done here.
Right. So as you say, the jumping off point is doing a good job of creating the building envelope so that we can control the loads inside the house. And as a consequence of having a good separation between inside and outside, we then get to use a smaller heating system. But because the house is tight, we also need a ventilation system. So this house has a HRV, a heat recovery ventilator, which will reside in this room we're standing in now, which is the mechanical room. And it also has a heat pump heating system. And I think really the most important thing is to say about this is that unlike many projects that we encountered, this house was designed with a place, the correct place to put all the mechanical systems. So here we're in the mechanical room. Like I said, behind me, these two pipes you can see in the wall, that's the intake and the exhaust for the HRV. So that's where our fresh air will come from and where the exhaust air will go out after it's been scrubbed of that energy that passes into the incoming air. And then up in the lid here is where we start to have our ducting runs. And down the long axis of the house, we have a chase that's over the hallway, and all our duct runs are there inside the conditioned space, although it's a well-made system and it won't leak. If it did leak, it would be leaking inside the conditioned space, so it's not as deleterious to the performance as if it were outside. And it gives us a place to actually route everything efficiently and send it to all the rooms that are going to get their heat and either their ventilation supply or their ventilation exhaust.
So in this house, you've designed the heating system to be one system and the ventilation system to be another system.
Correct.
And I think that's really important in these types of projects because you don't need heat that often. Mm-hmm. We're not running, it's not like a normal house where you're running the furnace all the time. Right. We're running the ventilation all the time when we're closing the house up. When the windows and doors are open, the ventilation system isn't essential because you get natural air. And let's face it, we're in California and Pebble Beach, and the environment here is extraordinary. And in future videos, we're going to talk about really how passive house isn't that different than normal construction. But in this place, like, we have the two HRVs. We'll have a big unit right here on the wall. Mm-hmm. That's going to be the heat exchange core. But then the air comes up, goes through this big duct, goes into this plenum, which then separates everything into these little 3-inch lines that you have everywhere. Right. And those go to specific rooms in the house to pull air out or to put air in. So we're pulling air out of the places we get moisture or smells, and we're then adding air back. And so you're kind of causing this circulation through the house to always make sure that the air is fresh, because so tightly sealed, and we do that so we can keep out that smoke and the exhaust from the cars and everything else, but we're never compromising the air quality. Right.
And I think an important concept for everyone to understand there is that everything in here is operating what I call low and slow. It's the volume of air that's moving is, I'm sure that most of you have had an experience where you have a forced air
blowing your hair back.
Exactly.
Well, not your hair. And very little of my hair.
Yeah.
But Bronwyn's hair.
Right. But the people, a lot of times people they complain about comfort issues, and most people are just used to them. And so it's almost subconscious that the house is going to be different temperatures in different locations. Because the house is losing heat quickly, there has to be a whole bunch more heat introduced. And so there'll be stratification or turbulence, or even people don't like to hear the noise. I mean, I have a lot of people that want to know if there's an alternate to a forced air system simply because they don't want that noise in the house. In this house, because we've again separated in the inside and the outside correctly, the house inside is going to maintain the temperature that it was designed to stay at, and just small inputs of heat or small amounts of circulation are going to keep the temperature perfectly consistent, top to bottom, end to end.
And because these houses are so quiet, because we've excluded, well, quiet from outside sound, right? If you have kids or loud parents or whatever, like they can be really loud inside. But because they're so quiet, we want that low and slow, because you're then able to hear it acoustically if it was a loud system, or if it was going from 0 to 100% on and off all the time, right? So how many BTUs or how many tons is this heating system for this 3,000 square foot house?
Yeah, so normally the sort of conventional system might be like 100,000 BTU furnace or something like that for a house of this size. And for a long time, the problem is that you couldn't get appliances that were the correct size, so you ended up oversizing simply because that was on the market.
Right.
But when you have a passive house, and frankly, part of the main reason that we're using a heat pump is because it's an electric appliance. It's not combustion based, but also they can be bought at a more different load levels. Size. Right. So this house is probably a 40,000 BTU house because it's so well insulated that we just don't need to add that much heat.
Okay.
One thing I want to add, our heat pump can do heating and cooling. So you get, it's a twofer. You get both heating and cooling, and we can moderate that and modulate it, and deliver that through the same system. It's kind of air conditioning on top of heating and cooling.
It's like air conditioning for free.
Right, exactly.
Absolutely.
It moves forwards or backwards.
Exactly. So it's, again, in conventional construction, we normally would have had a separate appliance and a separate system for an air conditioning system versus a heating system. And here with the heat pump, we only have to use the one system, and we get to have both.
Awesome. If you're interested in learning more about the 17-mile house or about building construction and passive house, click subscribe as we show you how to build a better way.